Okay, this problem is a volume by slicing problem. Over here to the left, we have a graph of the functions. This blue curve right here is the curve y equals 1.6x squared plus 0.7, which is a parabola opening upward. The red graph is the graph of y equals e to the 1.6x. That's like e to the x with a vertical stretch by a factor of 1.6. And here, this little purple segment is a typical side of a square that's perpendicular to the x-axis. And what we have to do is come up with an expression for the length of that segment, no matter where we are in this blue region. And that's going to be, since this is a vertical segment, the y coordinate at the top minus the y coordinate at the bottom. In other words, we've taken this distance right here and subtracted that to leave the length of that segment, the side of the square. And over here you can picture a typical square, which is having this expression for the length of the side of that square. And now the area of that square will, of course, be side squared. So there is a formula for a of x, the area of a typical square, side squared. And to get the volume of the solid created by having all these squares, you have to kind of picture a square coming up like this, where these are right angles. We want to integrate from, well, that's the other question. How do we find this point of intersection? You can use a graphing calculator to graph both these functions and find the point of intersection. Or you can use Newton's method, which you may not have learned yet. But here's an example of using Newton's method, where f of x is the top function minus the bottom function. And g of x is the derivative of that function. And here's Newton's method right here. And you can see we could actually get a value for the x-coordinate of that point of intersection that's much more precise than this negative 0.179. Okay, but there you go. You have to use a calculator to evaluate this expression where a of x is equal to this rather complicated looking expression there. There you go. I will include a link to a graph on Desmos that actually has this integral with a answer that you can look up after you've tried all this. So hope that helped. If you have any questions, post a comment.